Welcome to lesson 86. Well, we have some interesting topics to discuss here. First, let's talk about the trichotomy axiom. And then we're going to talk a little bit about graphing. And then we're going to go back to, we're going to go back to some irrational roots, which I just enjoy the splendor of that descriptive title, irrational roots. We're going to build up to them. Let's just start with the trichotomy axiom. And if we've got two numbers, and we're going to call them A and B, that's an and, exactly one of three things is true. Either A is greater than B, A is less than B, or A is equal to B. That, my friends, is the oh my gosh, look what I did. I drew a line through it. I'm so sad. I injured my trichotomy axiom. This is the trichotomy axiom. One of, if you've got two real numbers, A and B, either one's bigger than the other, or either the first one's bigger than the second one, the first one's smaller than the second one, or they're the same. Trichotomy, three parts. Only one of those three things can be true at a time. Now, the reason this is useful to talk about is that when we are doing graphing problems, like we see like in 86.3, example 86.3 on page 356, gosh, we're getting up to some really big numbers in the book. It tells us to graph x is not less or equal to than minus 4, sorry, and our domain equals negative integers. I'm going to abbreviate that a little bit so I don't have to write it all out. All right, so this is where our trichotomy axiom comes in. It's telling us that x is not less than 4, and it's telling us that x is not equal to negative 4. I should have said negative 4 the first time. So therefore, we can conclude that we're graphing x is greater than negative 4, because the trichotomy axiom tells us if it's not that one and it's not that one, then it must be that one. That's why that is such a useful and groovy little tool. So now we're going to draw our picture. We know we're going to need negative 4 in there. But notice that our domain tells us we're using only the negative integers, all right? We want them greater than negative 4. That doesn't include negative 4. It's not real numbers, it's integers, so that's counting numbers only. So I'm going to put 0 up here. 0 is not a negative integer, so he's not going to be in the solution either. So let's put in the dudes in between. Oh, mine's kind of out of scale, but just pretend with me. So we're graphing the negative integers only that are greater than negative 4. Boom. Boom, boom. There's your solution. Cool, huh? Kind of easy. 86.4 is not much harder. It's got a tiny wrinkle more. This time we're going to graph minus x plus 4. Where's my magnifying glass? Here it is. These little signs are hard to read. Is not greater than 2. And our domain equals the reals. Yes. Can you see that? Kind of. Okay. So our friend, the trichotomy axiom, tells us, okay, if it's not greater than, then it must be less than or equal to. So we can rewrite this. Negative x plus 4 is less than or equal to 2. Okay, so we've got that negative sign taken care of, that negative inequality. So now our next step is to say, dude, we've got an extra number flopping around here. We better take care of him. So we're going to subtract 4 from both sides. And we get minus x is less than or equal to minus 2, yeah? Okay, now, here comes a mind bender. Here comes a red alert. Pay attention, circle the wagons, call in the dogs, and put your brains to work on this. We want to change this negative x into a positive x. The way that we're going to do that is we're going to multiply both sides of this equation by negative 1. Now, I don't know if you guys have ever heard this before, but this is what I want to draw your attention to. When you multiply an inequality by a negative number, using the hash sign for number, and I'm underlining that, you flip the sign. Or you flip the inequality, let me say that. Okay, draw a big circle around it. People forget this all the time, but it's super important. So, we're going to multiply, oh look, I kind of lost my minus 1 there. We want to multiply this dude by minus 1 to make his minus sign go away. We're going to have to do this one as well. When we multiply an inequality by a negative number, you flip the inequality. So watch what happens. We multiply minus 1 times minus x, we get x. We flip the inequality. Notice we don't change whether there's an equal sign or not. We leave it just the way it is. We just flip him over. And then this becomes positive 2. Okay? Super important. I can't emphasize it enough. Negative numbers flip the inequality. They don't change it whether it's equal. We're not applying the trichotomy axiom. We're just reversing the inequality sign. All right? So now we're ready to graph. Let's put, we know we're going to need positive 2. We know that we're going to include it. Our domain is equal to the real. So instead of having dots, we're going to have a line. So we want to include 2 in our solution, and we want to go up from there. So you can put in as many other points as you want, but that's the basic gist of the solution. Can you see it? Yes, you can. There. You can see all of it now. All right. I'm going to let you guys handle example 86.5. I see right away in looking at it that there's a minus x, so I think that multiplying by minus 1 is going to be in your future. Make sure you pay attention to this groovy rule. Go ahead and do that, and then I'll meet you back here for 86.c, which is irrational roots. Buckle your seatbelts. There, I crossed off graphing while you were working. All right, you ready to do irrational roots with me? Here's another complex process that is going to pull all kinds of stuff from our algebraic past together. This time, we're going to be solving a system of equations that are nonlinear, and on page 357, it gives you an example of what our picture is going to look like. What we have with these equations is the first equation that we're going to have, I'm going to write it in just a second, it actually gives you a circle, and that is x squared plus y squared equals 9. When you have these two squared terms, you get a circle shape. It's kind of cool. We'll be working more with those later. And then our second system of equations is a line that goes through about like this, not precisely, but it intersects the circle at 2 points. And the equation of this line is y minus x equals 1. And I'm just getting this out of the book, by the way. I'm not making that up, okay? This is example 86.6. So what we're going to do, just like last time, is we're going to solve this system of equations for, we're going to come up with the pairs of x and y that will give us these 2 points on our picture. So we're going to tackle it much the way we did in the last lesson. We're going to start by solving this equation for y. We could solve it for x if we wanted, but we're going to do it like John did, and we're going to solve it for y. So we'll add x to both sides, and we will get y equals, that goes away, x plus 1. We need to square it in order to make it work there. So we have to square that side. And dudes, we can't square them individually. We have to square them as a binomial. So let's go over here and do that work. We're going to get x squared plus x plus 1. Add them up. X squared plus 2x plus 1. That is, I'll just write that here, or y squared equals this. Oh, you couldn't see all that. There you go. Y equals x squared plus 2x plus 1. Now we will say if these y squareds match, then that means we can substitute this in for that. Make sense? Okay. Scooch my paper back over so you can see everything. So now we're going to start with our first part of our first equation, x squared plus, and instead of y squared, we'll use this, x squared plus 2x plus 1 equals 9, we said. And now let's subtract 9 from both sides and combine like terms. So we get (2x squared), sorry, I was just looking ahead at the problem. Okay, these come together, 2x squared, let me draw the line, plus 2x plus 1 minus 9 is minus 8 equals 0. Okay? That's just substituting in and simplifying. Now I see that we can divide both sides. We can divide every term by 2 and simplify things a little bit. And we can divide the 0 by 2. That's fine. Don't worry, even though 0 divided by 2 is always 0. That used to freak me out. I used to think you couldn't do that or that somehow it was screwing things up. Nope, it's fine. So now we simplify again. We get x squared plus x minus 4 equals 0. 8 divided by 2 is 4. All right, now we want to factor this bad boy. Here's the thing. We could try factoring this by inspection, but you know what? It's not going to work. So what we're going to do, if you're ready, if you're excited, if you're pumped, I know I am, we are going to drag out the man-eating dragon. And we are going to let him solve this trinomial equation for its roots. We're going to let it come up with some values for x for us. I don't know if you guys have seen the James Bond movie Skyfall, but there's a scene where they're fighting with a man-eating dragon, and I was so excited about the whole thing. I can't even tell you. It was like a Komodo dragon. So, James Bond and his man-eating dragon are going to solve this problem for us. We need our quadratic formula. I'm going to write it over here. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Can you see that? There it is. There's our little man-eating dragon. Look out, James Bond. Don't let him bite you. Zach Cranny would be so proud of us for that. It's a happy day. Okay, now we set up our A and our B and our C based on our original equation. There's no number in front of the x, so that means A is equal to 1. There's no number in front of that was our x squared, our plain x, so that's equal to 1. And our C is minus 4. Remember, signs matter in doing this. So now we've got all of our tools ready. We just need to stir up. This is like our formula or our recipe, and these are our ingredients. And we're going to stir this together and make a delicious batch of roots, I guess you might say. I'll plug it in here, and then I'll simplify on the next piece of paper because I'm starting to run out of room. So let's do this. X equals minus b, so that's minus 1, plus or minus the square root of, what's b? 1 squared. I always use buckets, especially inside the square root house because it's a complicated calculation. Minus 4 times a is 1, and c is minus 4. All over, the whole thing is over 2 times 1 So that'll be easy, won't it? And I have time for one more simplification, or I have space on my paper. So it's minus 1 plus or minus the square root of 1 squared is 1 minus 4 times minus 4. So this is going to be a positive. I've got two negative signs making a positive. 4 times 4 is 16. The whole thing's over 2. All right. I'm going to do this. I'm going to drag this paper up so I don't have to rewrite anything. We can see it up there. Okay. So now the next step is, oh, here, let me pull this down. How am I doing? Have I messed you up yet? Okay, that looks pretty good. So now we've got minus 1 plus or minus the square root of 17 over 2. How does that sound to you? Pretty good? So now, this is x equals, by the way. I didn't write that. So now let's write out our two different things. Either x equals minus 1 plus the square root of 17 over 2, or it equals minus 1 minus the square root, it should be 17, square root of 17 all over 2. Yeah, that's our right answer. You could write it one more, you could clean it up one more step. John likes us to write them like this. Oh, wait a minute. We still have more to do, though, because we know that these are our x's, but we now need to find out our y's. Don't you just want to jump off a bridge sometimes? Okay, I'm sorry, that was not the team spirit. Square root of 17 over 2. I'm writing these, instead of one combined fraction, I'm writing them as separate fractions, because that's how John likes to roll, okay? And now, if this is equal to x, we have to go back to our original equations, which I'll slide them down so we can see them. If we look at our original equations, we see that, where did we reshape this one? Y equals x plus 1. Okay, so if we use that here, if we use y equals x plus 1, then we know that y equals, in this case, minus 1/2 plus square root of 17 over 2 plus 2 over 2, or in this case, it would be y equals x minus 1/2 minus the square root of 17 over 2 plus 1. Instead of writing 1, I'm writing 2 over 2, because that's how we're chilling here. Do you see how I got from, here are our x values, and then I used this version of one of our original equations, and then I plugged our x values in. There's our x. There's our other x. And added 1, just like this equation dictates, only I added it in the form 2 over 2, so the denominators would match. And now we're ready to calculate our corresponding values for y. So if I combine this much and this much, I'll get y equals positive 1/2 plus square root of 17 over 2. I keep making that a 12. And then this, I do the same thing. I combine my values of y, and I get y equals positive 1/2 minus square root of 17 over 2. And before we faint from the complexity of all this, we're simply going to write our x. We've got values for x. We've got values for y. We know that they match up. This one goes with that one. They match up like that. So now we're going to write them as ordered pairs. So the solutions for this system of equation, or in other words, let me slide this down, the names of these 2 points are minus 1 over 2 plus the square root of 17 over 2, comma, that's the x, here's the y, positive 1/2 plus the square root of 17 over 2. That is a point, you guys. That is an x and a y that show up on this little diagram. I didn't draw this perfectly, so they might not make perfectly logical sense, but the idea is that that would be one of this kooky combination of numbers describes one or the other of those points. And I guess it would be this one because it was minus first. So it would be this one. And now let's summarize our, let's see, can you still see where I'm working? And now, so that's one point. That's the one we calculated on this side. And so then the other point would be, here's our x minus 1/2 minus the square root of 17 over 2 is the x value. And then the corresponding y is 1/2 minus the square root of 17 over 2. Very, very similar, aren't they? There's a minus and a plus. There's a plus and a plus. There's a minus and a minus, and a plus and a minus. So each one of those points is different, but they involve the same combination of numbers. All right, suffice it to say, that whole long process, using all of those different steps and ideas, served to allow us to solve this nonlinear system of equations for two values for x and y. We knew there would be two values for x and y because they were squared there, and also because of the way our picture is drawn. Okay, so these are the 2 points that show up on our graph. If we drew it properly, it would probably make more sense, but I just drew the picture. Okay, wow, that's a lot of work, you guys, and that's a lot of complex work. So again, I recommend highly that you use your study guide and check your answer step by step so that you don't get too far off track before you realize that some little thing went out of whack. And, you know, honestly, it's a miracle that I get through these problems with getting every single detail right. That's what happens when you've been doing algebra for years and years and years. But honestly, I would not expect one of you guys to get through this whole complex calculation without any mistakes. So there will be little mistakes. That's not a problem at all. Just use your study guide, your solutions manual, to check them and find them as you work so that you can increase your precision and not drive yourself crazy in the meantime. All right? That is lesson 86. It's a doozy. Good luck with that homework.